Graphing. In my experience, students don't like to graph, and I don't know why. I really like it, but let's refresh on how to graph lines and quadratics. So what we have right here is if you have a linear equation, which means you have an x and it doesn't have an exponent. Its exponent is technically 1. And it's written f of x equals, which is the same as y equals, then you have an equation that's in y equals mx plus b, which is slope-intercept form. So in this case, I know the slope in that situation right next to x is 1/3. I know the b, the y-intercept, is -7. So if I know that I have a y-intercept at -7, that means that this line will cross the y-axis at -7. So go to the y-axis, find where it's -7. So we're going to pretend these are all counting by 1, 2, 3, 4, 5, 6, 7. All right, then you're going to use the slope to find the other points. Slope is always rise over run, okay? Positive 1/3 is going to go up 1 and to the right 3. Up 1 and to the right 3. Up 1 and to the right 3. When you run out of room, you can always go back to the original and reverse both of these. So instead of going up, you're going to go down, but if you reverse that, you need to reverse the bottom. So you can go down 1 and left 3. Down 1 and left 3. Connect all of your points as straight as you can. And that is how you graph the equation of that line. All right, number 32. Number 32, the only difference is the inequality. It is the inequality instead of the equal sign. So we're going to graph the rest of it the same way. My slope is 3. My y-intercept is -5. So start on the y-axis at -5. Now, in order to use the slope, you need an up and an over, or a down and an over. So we're going to make this a fraction by putting it over 1. So we're going to go up 3 and right 1. When you run out of room, go back to the start and reverse both directions. All right, now, before you draw a line for an inequality, you have to remember a couple of things. Greater than or equal to and less than or equal to are solid lines. Greater than and less than are dashed lines because you can't be equal to the line. We have an equal to situation, so we're going to include the line and we're going to draw it as a solid, normal looking line. Then you also need to remember that greater than symbols and greater than or equal to are shaded above. Because you're saying that the y values are going to be greater than the line that you drew, and y values get greater when you go up. The reverse of that, if you have less than or equal to and less than, those shade below. Because the sentence would say that y has to be less than the line. Well, we have a greater than situation, so we're going to shade everything that is above this line. Now, what you're saying now is you're saying that all of the answers to this inequality are anything that's in the shaded area, so this point or this point or this point, or anything that's on the solid line. If it were a dotted line, it would not be included in the answers. When you have an equal sign, you're saying that all of the answers for that situation are on this line that we drew. So if it's a solution, it's going to be here or here or here or here. And that's really what that's saying. All right. The next one, y equals x. Y equals x is technically written in y equals mx plus b. It just doesn't really look like it. So the number that's being multiplied to x is 1. We have 1x, and we're adding nothing to it. So this is going to start on the y-axis at 0, and then your slope is 1, so 1 over 1 is how you can make it a fraction. So up 1, right 1, up 1, right 1, and continue all the way, or go the opposite way. So that's the equation y equals x. All right. Oh, no. Okay, two more. Y equals x squared. Y equals x squared is a quadratic graph. So instead of being a straight line, it's going to have a curve to it, and we know that because of the 2 on top. So in order to figure out how to graph this one, because we can't use y equals mx plus b because it's not a line, we're going to build a table. And we're going to have x values and y values. And we're just going to pick a couple x values. So I'm going to go -2, -1, 0, 1, and 2. All right, let's start at the bottom because it's easier. So if I have 2, and I want to know the y value when x is 2, then I'm going to take my equation, and I'm going to say, okay, I'm going to use 2 for x and square it. Well, 2 squared is 4, so y equals 4. Same thing if I want x is 1. So if I picked x is 1, 1 squared is 1. All right, then again, I'm going to keep going up the table. The next x I picked was 0. So if x is 0, 0 squared is 0, so y is 0. Then I'm going to use x is -1. -1 squared is the same as -1 times -1, and that's a +1 answer. Then the last one, -2. -2 squared is the same as -2 times -2. That's a +4. Okay, so now I have quite a few points that I can plot on my graph. So the first point I'm going to plot is x is -2, y is 4. So when x is -2 and y is 4, that happens here at this point. So when x left -2, y up +4. Now the next point, if x is -1 and y is +1, that's there. Then 0, 0, then 1, 1, and then 2, 4. Then we can connect these in a curve that's called a parabola, and that is the graph of y equals x squared. Okay, last one. The difference here is I have a system, which means I have more than one equation being graphed together. Now, technically, these brackets should be one single bracket to show that they're the same problem, but I couldn't figure out how to type that. What's different between these is, if you notice, x is just an x, so we know it's going to be a line. It's going to be linear. There's no exponent on x. It's just 1. But it's not written in y equals mx plus b. So first, we need to solve them both for y equals mx plus b. So if I take 4y minus 2x equals 4, I need to isolate or get the y by itself. So first, we're going to move the 2x's. So if I add 2x's, then I will have 0 left on this side and only 4y. But I have to do it to the other side as well. Now, 4 and 2x cannot be combined. They're not like terms. So I'm going to keep the 2x and the +4. Now divide everything by 4. So y equals 2 over 4 is the same as 1/2 x, and 4 over 4 is the same as 1 whole. Okay, now that is written y equals mx plus b. So I'm going to go ahead and plot that. So we start where the y-axis is 1. We go up 1 and right 2. And then we can go the opposite direction. Okay, now connect our points. Whoops, that was not very good. Okay, now let's graph the second equation on the same set of coordinate plane or coordinate grid. So 10x minus 5y equals 10. So I'm going to subtract the 10x's first. So I have no x's left here, but I have -5y equals. Those cannot be combined. Even though they're both 10, they're not like terms because one has an x and one does not. So I have -10 x's and +10. Divide everything by -5. So y equals -10 divided by -5 is a +2. 10 divided by 5 is a -2. Now it is written as mx plus b, so we can plot the points. So we're going to start where the y-axis is -2. And then we're going to use our slope as a positive 2, technically positive 2 over 1. So up 2, right 1, up 2, right 1, up 2, right 1. And we can go the opposite direction as well. Connect your points. Now, this question asks you for a solution. The difference between this and the reason I didn't ask you for a solution on the others is when you have an equation like on number 33, you have a lot of solutions. Anything on this line is a solution. So all of those points are solutions. But when you have two equations together, you don't have a lot of solutions. You have a lot of solutions on this line by itself, and you have a lot of solutions on this line by itself. But there's only one solution that satisfies both. So the solution to the system is where your two lines intersect or come together at that point, which is 2, 2.